Welcome to the DevOps Engineer Level 4, where we introduce K2, the Principles of Distributed SCM. Well, to give it its longer title, the Principles of Distributed Source Control, including how to exploit the features of the tool, such as branching. Now, the idea of being distributed is that you can be working with local code and even offline, so on the bus going home. And who doesn't like to do a little bit of their work on the bus going home? Out there front and centre in the world of distributed source control management is Git. It has always been there and was developed originally by Linus Torvalds, the creator of the Linux kernel and the father of the Linux operating system. So let's begin by taking a look at two lab systems connected to a central repository and how collaborative branches can work nicely together. So we have two client systems that we can work with, an Ubuntu system and a Rocky Linux system that you'll see later. I've already cloned the repository, and this is a shared repository, and we're using a shared file system to be able to access this. But as you can see, it's brand new. I just have the .git directory and nothing else. So time to create some content. I'm not going to worry about a branch to begin with because at the moment, well, we don't have any content, so it's easy just to add to the master branch. Especially with this simple script, we don't need to do too much, so we're just going to go through and echo simple scripts and send it through to the README file. And with that done, we know then that we've added something to our file system. We can see that we've got the README file there, but we're going to need to add it to our staging area. So we can use git add and adjust everything from this directory down. And of course, we can then follow this up with a glorious commit. So we can put our commit, the commit message, and this then is taking it out of the staging area and putting it in the repository. We have the three locations, our local file system, the staging area, and then we have the repository. But everything is still local, so we could be working offline. Using the git push, we're then pushing it back to the centralized repository. So the idea of distributed is that developers can work on their own content locally and push it up when required. Now you can see the consoles have different colors, so I'm now working on the Rocky system, and we can go through and clone the repository. This is a shared file system between the two systems, so I can go to the Vagrant and repo directory and clone that, and of course that's going to clone to the repo directory in my home directory. So as I look at this, I've now got that glorious README file that was added before. But we can now start developing. And if we're starting developing code, we really should consider creating branches. Branches then allow for our production or master code to be kept separate. So I can then use git checkout -b for a new branch if it doesn't exist, and we can go through and specify and try and keep the name unique and identifiable. I'm meant to be the Rocky user, so I can go through then and have Rocky and script1 showing what I'm working on. So now I've moved into that branch. The branch is going to be at the same location as the master branch, so I still will have the README file. But as I start making changes, we're going to drift away from the configuration state of our master repository. Now, it doesn't really matter how we edit the file. On this system, I can use the Vim text editor, but you're welcome to use the Nano text editor, but it doesn't really matter. It's just editing text files. So I'm going to edit then script1.sh, and I can go through and add in the shebang line, so indicating the script interpreter to use. And then I'm going to have something really simple, just 2 lines, and I can echo out hello. I'm not even going to bother with hello world. Let's just have hello. We can go through and save the changes, and we're done on our editing. But I do need to add in the execute permission, so the script will execute. So A plus X, so chmod, changing the mode, all plus execute for script1. When I list it now, the green, the color coding, indicates it's executable. So it looks like it's ready to go, but I'd like someone to check this. So I can use git add, and we can add then either script1 or the complete directory. It doesn't really matter. There is only the one change. So I'm using git add dot. So everything that has changed or modified within my current directory structure, and I can have my commit message, and again try and make it meaningful. So add script to show output. That's as meaningful as I can think of for the moment. And we can see then that we have created the file, and it's created with the mode, as we can see. Now the origin doesn't have my branch, so I have to run a git push to the origin and then the Rocky script1 branch. I can type it out, but I can also use tab completion if the branch exists. So we can go through then and put our script1, hit enter, and now my local branch has been pushed up to the server. So moving back to the Ubuntu system, when I use a git pull, we can pull any changes back, and that comes, and we can see the new branch has been added. Now that won't have changed my local branch, but we know about the branch now. So listing, I only see the README file, and I can clear the screen with Control and L and run it again, so it's a little bit clearer. If I now go through and check out the Rocky script1 branch, I can see now that I have both the README and the script1, and I can go through and execute script1, and we can see that it executes perfectly well. So it looks like the code that has been created by Rocky is good, and we're happy with it. But branches also have another feature, is that I can check out a particular branch. So if I move back to my root file system and delete my local working directory, remember I haven't made any commits there, so it doesn't really matter. And then I can go back to my git clone command, and if I add the option -b, I can then clone out the particular branch that I want. So now that I've cloned that, if I move back into the repo directory and get a listing, then it's cloned with both the README file and the script1. I can check the status, and we can see that I am indeed in the Rocky script1 branch. Had I not used the option -b, I would have cloned the master branch, and I would have only had the README file and nothing else. But if I'm really happy everything is working now, I can check out my master branch. Again, checking out the master branch is going to give me just the one README file. But I can choose now to merge the verified and validated content of the branch back into the master branch. So now the master branch has both files, and I can make sure that the server knows about this by pushing the changes back up. We've now seen how we can collaboratively work on a project with remote clients, pushing up the changes as required, and having some other third party check our code. We'll now see how we can implement tags to create frozen code versions, so we can always download that version and we know it cannot and will not be changed. Working on my Ubuntu system, we're going to start developing a script, but a script that will have two distinct versions. One that needs to be frozen, that will work with the Ubuntu system, and one that will be frozen, that will work with the Rocky system. So first off, we're developing a branch. So I've created the Ubuntu Apache branch, and I can go through and create my install.sh. And inside of this, we can go through and install the Apache web server. Now, the process is going to be different between Ubuntu systems and Rocky Linux systems. On an Ubuntu system, we have to use the apt packet manager, and we need to update the cache first, and then go through and run the install. Additionally, the package is going to be different. It's called Apache 2 on Ubuntu, whereas it's called HTTPD on our Rocky system. Now, I know I could write if statements to cater for all of this, but we're just going to show you two different scripts that will be the same name, but we can choose which one we have based on the tag we assign. So now, having developed this, I'm happy it's going to be working on my system, so I'm not going to worry about testing it. We can just go through and add it, and we can run our commit message, so we're saving it back through to our branch. And once this is done, we can put a good commit message. So this is the Ubuntu install for Apache. And with that ready to go now, as I say, I'm quite happy that it is working. So I can check out my master branch. And I can go through and merge back into my master branch. We're just showing you the best practice by creating the development branch first, but I've moved back into my master branch. Now I can keep it local, but good practice would be to push it back to the server at this stage. But this is going to be the installation script for Ubuntu, and we want to be able to check this version out at any stage, and we don't want this to be changed. So this might be a particular version number, like version 1.0, or, as we're talking about here, a particular named script. So we do this with tags. So git tag. We can annotate the tag, so the tag name. So we're calling this Ubuntu. And we can put a message or an extra detail if you like. This is optional, but we can call this version 1 script for Ubuntu. And with that done, hit the big enter key and the tag will be created. Now tags, unlike branches, can't be developed further. They're really read-only copies, whereas of course branches can be developed further. I can then go through and push it back, and I push it back in very much the same way as I would a branch. So I have to then mention I have to push to the origin and then the tag name, so Ubuntu. So now that's been pushed back up onto my server. Now, of course, I can list the repository, and all I've done is save my state to a tag. I haven't moved to the tag, so I'm still working in my master branch. And of course, this then is going to work in our normal way, where we can continue our development as required. However, if I check out the tag, we will see the big difference. Tags are read-only, so we can't add or change the code within a tag. Well, we can, but we're always going to be losing that code. And that's the idea. These are frozen versions, so we're guaranteed the content that we're going to be getting. I can check that it's working. If I run then the install script, it's working the way that I want, so I can access it. And we can see then the web servers being installed and everything has worked the way that it should. But this is for Ubuntu. It's not for Rocky. I can check if I like. With the SS command, we can show the sockets and we can see that we're listening on port 80. So we're really happy that the web server is up and running. I am still working within the tag, so I can then go through and check out, and we can use tab completion to see what's available, but I can then check out the Ubuntu Apache branch again. The branch name doesn't really matter for the moment. I just don't want to create another branch. But from here, I'm going to go through and look at the install script, and we're going to modify it so it will work with Rocky. So we don't want the apt installs. We don't need to worry about an update. We just do a yum install -y, and then we can go through and add in HTTPD. Both the packager is different and the package name. But additionally, Rocky doesn't auto start or enable the service. So I need to add that into my script as well. So you can see why I need the different scripts, but it's convenient to have the one name. In reality, I could cover this with conditional statements inside of the script. But we can now go through and add this. We can go through and commit this. And we can now say this is the Rocky side of things being done with our commit message. And we can save that. So all of this has been saved locally. We can run then our git command and check out the master. And now we're ready to merge back. Again, ideally we would check this before we do any of our merging. But we can also see that I'm one step out. So let me push the previous change back. So we've pushed that back, and now I can go through clearing the screen and run my git merge and merge the Ubuntu Apache system back in. So my central repository is now up to date. I can push these changes back. And we're just about ready to go now to set up another tag. Another tag is going to allow me to have a frozen version for the Rocky. So as I go through, I can now go through and annotate the tag, name it as Rocky, and perhaps change the message that goes with it, the description really. We now have two tags, the Ubuntu tag and the Rocky tag. They're frozen in time, so they're always going to be the same. We just need to push the Rocky tag back up to our system so the central repository knows about it. And now I can clear the screen and I can move back into my home directory and I can remove the repo directory. So this is my working directory that I've now removed. Remember, the central repository is still there. When I go back to my clone command now, I will clone it in the same way as a branch. So -B, and I can clone the Ubuntu branch. So this is going to have the Ubuntu version of the script, frozen in time with all of the apt elements. Again, I get the warning that I'm in the detached head, so this isn't something for changing, but then allows me to go through and execute the code from this point. So that's brilliant. My code is working and it's a known state that is never going to change. Well, okay, let's move across now to our Rocky system so we can see the Rocky system will work with its version. So again, I can move to my home directory. I can run the clone, so git clone. -B for the branch, but remember it's a tag now. Rocky is the tag. And then I can put the path. Ours is a file system, but yours would be the HTTPS URL of your repository. Okay, I forgot to delete it, so that's not going to be a problem. So let me go through and delete the original directory. And now go back and run my clone again. And now we, of course, are cloning the Rocky version, which is going to have the yum versions of the installation script. So I can then run bash and repo install.sh. And we can see now that this is working correctly for the Rocky system. Oh, the only error there we're getting is that I called the service HTTP instead of HTTPD. So it shows you the importance of testing everything before we create our tags. Of course, I could go back and correct that now and create a new tag, but I'm happy to leave it the way that it is. You should now be a little bit clearer on both branches and tags within your version control system. Branches are for development. Tags create frozen versions. We work in branches, we then merge and then finally create our tags. Summarizing Knowledge Area K2, we've seen the principles of our distributed source control, or Git, and we've seen how we can exploit the features of the Git tool, such as branching and tags.
All that is left to say is thank you for watching. If you've enjoyed this, then you are probably sadder than I first thought. For more of this drivel, please subscribe, like and comment to @TheUrbanPenguin.